Hi, in this video we are going to learn the written proof of few of the DeMorgan's law. So the two laws for which we are going to learn the proof, they are already there on the screen. So the first one, if I take, the first one says A minus B union C is equal to A minus B intersection A minus C. So suppose if I take X as one of the elements of A minus B union C. If X is the element of A minus B union C, that means X will be an element of A and X will not be an element of B union C. If X is an element of A minus B union C, this A minus B union C actually represents all the elements of A which are not there in B union C. That means X will be an element of A and it will not be an element of B union C, right? From here we get X is an element of A, as it is I am writing, and X is not an element of B, and at the same time it is not an element of C also, because if it is an element of either B or C, it will definitely be there in B union C. And since it is not there in B union C, it will not be in any of the two sets, that is B or C, right? And from here, we can say that X will definitely be an element of A minus B, right? Because X is in A and X is not in B. And at the same time, X will also be an element of A minus C, because X is there in A and X is not there in C, right? So X will definitely be an element of A minus B and A minus C, and that is why X will be an element of A minus B intersection A minus C, right? Since X is the element of both A minus B and A minus C, it will definitely be an element of their intersection, right? And what is this? This is nothing but the right hand side of this law, first law. So from here we got A minus B union C is actually equal to A minus B intersection A minus C, right? Or we can write it like this: A minus B union C is actually equal to A minus B intersection A minus C, right? And this is the written proof of this law. Okay, and now we are going to prove the second law. So let me erase all this. The second law says A minus B intersection C is equal to A minus B union A minus C, right? So again we are going to assume X as one of the elements of A minus B intersection C, right? If X is an element of A minus B intersection C, that means X is definitely an element of A, right? But it is not an element of B intersection C, right? So that means X is an element of A, but X is not an element of B, or it is not an element of C, right? If it is not there either in B or C, it will not be there in their intersection, right? Either it is in B or it is in C, or it is not in any of them. That means X will be there in A minus B, or it will be there in A minus C. That means X will definitely be there in A minus B union A minus C, right? See, we can have two conditions. X is there in B and X is not there in C, then also it will not be there in B intersection C. Second condition we can have X is not there in B and X is there in C. And the third condition which we can have is X is not there in B, and X is not there in C. These are the three conditions which defines that X is not there in B intersection C, right? So if we take first condition that X is there in B and not there in C, in that case, X will not be there in A minus B because X is definitely there in A. So it will not be there in A minus B, but it will be there in A minus C, right? Yes? And if we take the second condition where X is not in B, in that case, it will be there in A minus B, but it will not be there in A minus C. And the third case, X is not there in B and X is not there in C. In this case, it will be there in both A minus B and A minus C, right? And in any of the case, it will definitely be there in their unions, right? If X is there in A minus B and not there in A minus C, then also it will be there in their unions. Or if X is there in A minus C and not there in A minus B, then also it will be there in their union, right? So X is definitely there in the union of A minus B and A minus C. And this is nothing but the right hand side of this law, right? So from here we can say that A minus B intersection C is actually equal to A minus B union A minus C, right? So this is the written proof for the fourth DeMorgan's law, right? And we have many more interesting videos in Math Smart, so keep watching Math Smart and look forward for the upcoming videos. So bye bye till then.